The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. This is Stacy Kruzik from the Zebra Developer Relations team. Hope you all are well today. We're very excited to have this DevTalk on the world of machine learning with Rafael Filicek. And we are going to first start off by doing some housekeeping things and letting you know about a couple of events that are coming up. We are getting geared up and ready for AppForum 2019. It's going to be in 4 locations this year. We're starting off in Warsaw, Poland. Then we're going to Sydney, Beijing, and we're going to, of course, end up in Las Vegas once again. Important to note here, we are taking an approach as far as AppForum this year to include, as we did in the last AppForum, a thought leadership track, as well as a developer track. So we're opening up this forum again to those varying audiences. To learn more about it, if you'd like to pre-register, or as we call it, sign up for interest, please go to the link and learn more at www.zebra.com/appforum. And you can get information on each event. The other thing to note is that we are looking for sponsors right now. Prime sponsorship opportunities exist. And we are also opening this up to submission of papers. If anyone has some exciting topics that they'd like to share, some insight on technology trends, we encourage you to submit a paper as well. And all of that can be found on all of the AppForum individual regional sites, if you'd like to go to those, or our global site on the link noted below. As always, we encourage you and invite you to participate in our developer community. If you go to developer.zebra.com, please sign up for news, information about DevTalks such as this one, our Dev podcasts, and we have our DevBuzz newsletters that go out monthly and quarterly in various regions. So we'd love for you to come and participate in that. For today's talk, we're asking that if you do have questions, that you wait until the end of the talk. You can go ahead and post those, and we'll make sure that we try and provide a response to those. So with that, I am going to turn over to Rafael. Are you there?
Hello.
There you are.
Can you hear me?
We can hear you. Fantastic.
Thank you very much, Stacy.
Absolutely.
So let me overtake. So hello, everybody, and thank you for joining this DevTalk. Let's talk today about machine learning, democratizing the world of machine learning, or maybe using another words, machine learning for everybody. Is it possible to make such a rocket science so simple that everybody can use it and profit from this? Before we look, however, for the answer, let us see what is our agenda. So just 4 simple points with a short introduction to machine learning, then intro to Tensorflow Framework, and in the end, I will show some interesting implementations of machine learning and TensorFlow today. And when I say today, it means that tomorrow there will be already some new implementations done by thousands of contributors. Last, I want to show you different possibilities to implement image classifier on the server and in the mobile Zebra device. So let's start. What is machine learning and how it differs from the normal programming? The biggest change is the way how to get the solution. Let's analyze the task of human activity detection, like laying, sitting, standing, walking, and running, in the standard and in the machine learning approach. In standard approach, left picture, the programmer himself would analyze the data coming from the sensors, and he would write a program to implement his own observations as formulas. It is so-called hand engineering. In the machine learning approach, right picture, the programmer constructs an algorithm which will learn itself this formula based on the input data. It means that machine learning will provide the model, transforming the input data to the output result. But how to get this model? It is a process. First, the machine learning expert is choosing the range of possible models according to his knowledge. And then he trains it using the set of input data called training data. Third step is to do prediction, to verify the model by inputting different set of data, which were not seen before, called test data. This leads to the final step, which is evaluation of the model. And then again, the expert changes the parameters of the model or chooses another one and iterates to get the best possible result. This is very long-lasting task, and you still need a machine learning expert to do it. And you need also strong computation power and patience. So no doubts that we see more and more trials to generate the best possible model in an automated way. This process is called AutoML. The results are more than promising. The graph shows the comparison of models generated as AutoML, the red ones, with models generated in manual way, black ones. You can see that with AutoML, you get the good model faster and with better accuracy than using classical manual way. So in the near future, this complicated and long-lasting process of getting the best model will probably be done automatically. Before it happens, however, let's see how to proceed in this manual way. It would be almost impossible to program the process of generating models in the low-level programming language. To make it possible, there are on the market several machine learning frameworks which abstract the low-level layers of programming and make it easier to design the models, train them, tune, and debug. We will focus today on Tensorflow, machine learning framework developed by Google Brain team. There are three important characteristics of Tensorflow framework. It is an open source project. It is possible to run it on the different hardware platforms in the cloud and even in the browser. It is easy to distribute the calculation and make the process parallel to get the result faster. But why this name, TensorFlow? Because the machine learning model which scientists are trying to find and tune can be described mathematically as a series of algebraic computations done on a geometrical objects called tensors. What is tensor? Depending on its rank, tensor can be a scalar, so one number, when it is rank 0, or vector of float numbers when it is rank 1, or matrix when the rank is 2, or n-dimensional array of float numbers when the rank is n. And why flow? To better see and understand what happens during model calculation, the scientists use a graph. And in this graphical representation, we can see that these often multidimensional tensors are flowing from one node to another. Each node represents a certain Ri calculation, which is transforming one tensor to another. And the edges are representing the flow of these tensors and the data. When downloading and installing the TensorFlow, we get a lot of tools. First, there are libraries and engine for training and testing. Then, to better understand the created model and do debugging, we have also the Tensor board. With the TensorFlow, you get also a light version to implement inference in mobile devices. Another important part is TensorFlow.js, which enables running TensorFlow direct in the browser. And last but not least, TensorFlow Hub, which is basically a repository of ready modules and models for reuse. A few following slides come from Google TensorFlow Dev Summit 2018. Architecture. TensorFlow started as a library for numerical computation with a focus on deep learning and neural networks. But it has grown to include a very rich collection of machine learning algorithms. The engine can run on many different hardware, starting from cloud, servers, PCs, mobile devices, and IoT devices, including Raspberry Pi. You can program in TensorFlow with lower APIs using Python, C++, Java, or Go. Then you can build the model from scratch. However, you can also leverage higher level APIs from Layers, Estimator, Keras, or even Canned Estimator. Keras we will see in the example soon. When you implement the higher level APIs, you escape from the detailed bit and bytes view and get more general and readable image of the process. Why abstracting lower layers is so important, please have a look at the simple deep convolutional neural network. This image is coming from TensorBoard, which is a part of TensorFlow Framework. Network consists of several nodes like convolution, pooling, dropout, dense, etc. To build this network without any framework, you would have to program each node and data flow manually. The code would consist of several thousand lines. Very challenging to code and debug. And many developers would give up before finishing. You can use, however, the TensorFlow framework, which is abstracting for you these low-layer programming tasks, and comfortably construct this graph in Python using a few lines of code. The higher the layer is, the less code will be needed. Let's see how you can build the graph using TensorFlow. Here we build the graph using the TensorFlow layer called Layers. It is only a few lines of Python code. Each line represents generation of one single node in the graph. It looks clean and elegant, and the developer still has a full control of the graph he's building by using parameters of each node. So this is probably the reason why in 3 years since launching, the TensorFlow has quickly grown to become the #1 machine learning platform. Here you can see the popularity grow as GitHub stars. More than 100,000 stars. In August this year, TensorFlow crossed 16 million downloads. And since it is an open source community, there are over 1,600 contributors to this project. And they are located in every single time zone in the world. These are the self-identified locations of users using TensorFlow in GitHub. Here are some well-known implementation of TensorFlow done in Google products, including voice and sound recognition, text translation for more than 100 languages, image recognition, time series for building recommendation systems, and video detection. And outside of Google, so presented slides come as well from the TensorFlow Development Summit 2018. In astronomy, discovering new planets in our universe is not an easy task. These planets are small, cold, and dark objects compared to their host star. Recently, researchers and astrophysics have analyzed large amount of data from the Kepler mission, and by using machine learning, they have recently discovered a new planet called Kepler 90I, making it the first 8-planet solar system we know of other than our own. In healthcare, looking at scans of the human eye, machine learning can assess a person's risk of a heart attack or stroke. This was not known before. Just imagine if this screening can be done on mobile device, and suddenly the whole world has access to easy, rapid, affordable, non-invasive screening for heart diseases. This could save many lives. In aviation, engineers and air traffic controllers in Europe are using machine learning to predict the trajectory of a flight through the airspace above Belgium, Luxembourg, the Netherlands, and Northwest Germany, which has more than 1.6 million flights per year, making it some of the most dense and complex airspace in the world. In agriculture, one Dutch company implemented machine learning to track cow behaviors and early detect possible health problems. So now, happy and healthy cows come also from the Netherlands. In medicine, a company, Johnson & Johnson, and Google have a plan to release in 2020 a medical robot to perform laparoscope operations. Robotics, computer vision, and machine learning comes here together. In transportation, utilities, and home medicine, the company Anyline in Austria embedded TensorFlow Lite application to perform a real-time text recognition on mobile. There are several interesting use cases, inclusive ID or passport data capture, reading utility meters or blood sugar level, filling delivery documents, or scanning car license plates. Achieved accuracy of recognition is high, even if device is offline. This is an example of so-called transferred learning, where machine learning model has been transferred to the device and gets this intelligence which was learned on the server before. And last but not least, zebras on the Savannah. Yes, it is true. Zebra has its cloud platform called Savannah, where all zebras, but also other animals, can live together in freedom. Savannah platform allows our ISVs and system integrators to build a variety of technologies such as RFID, barcodes, cameras, ultrasonic or other sensor-based system into a single solution, and the platform is designed to keep some computing on the edge. Our newest mobile devices, based on Qualcomm Snapdragon SD660 platform, are best suited for machine learning calculations because there is a dedicated hardware component for it. So how it works together? Smart sensors and Zebra devices can securely collect operational data from the edge of the business. Then Savannah stores, processes, and integrates the information collected, combining real-time data from devices with historic data to create a complete picture and intelligent insight of your business. And finally, Savannah powers applications with our APIs, enabling your solutions to recommend the next best move, to boost efficiency and optimize your workflows. Following 4 slides show Zebra applications powered by machine learning. Simulscan. The machine learning is decoding not only multiple barcodes or text on the paper, but also doing the OCR on a curved tire, which is difficult. Mobile dimensioning. Machine learning is being used to recognize and dimension the object. Smart Pack. In transport and logistics, machine learning is being used for machine vision and predicting load completion times. It helps also to better optimize space, to ship less air, and reduce operating costs. In retail, Smart Lens is being used to improve in-store inventory. It allows also to associate items to people, so it can help to predict and protect against theft. And this is just a beginning. So how to start with machine learning? I recommend to start with a simple example to understand the general principles and rules. Like this example implemented lately by Apple. Apple has released the newest macOS called Mojave 10.14. In this OS, you have already the Create Machine Learning framework with built-in models. The advantage of this is that you do not need to define the structure of the model. You need just to define the weights and biases. So model is about 100 kilobytes size and not 10 megabytes. In Xcode Playground, we will see the example of image classifier and its workflow with data, training, and evaluation. Now it's time for a short video. So as you see, you need only 3 lines of code to start the classifier. You get also a possibility to play a bit with some hyperparameters. First, you have to prepare your images and put them into folders, and then just drag and drop your images to Classifier window. And then the training starts, and the model will be tuned to your specific images that you supplied. So it takes about 1.5 minutes. I will cut. And now drag and drop my test images, so different kind of images, to the Classifier window, and it will start testing. So these images, the Classifier did not see before, so they will be like a testing. Takes about 2.5 minutes, so we will also cut video not to wait so long. Okay, and now we can see that the real accuracy is 97%, and we have only 3% of misqualified images, the red ones. We can also see and toggle which devices classes behave good, which not. Important is that we have here also 2 other metrics like precision and recall. So when we are happy with the result, we can retune, but when we're happy, we can save the model. And you can see the model is saved. Image classifier, ML model. And we can see that it is only 130 kilobytes on the disk. It is very light. So this was the first video. But you can also start easy by using Keras. There you will have to program a little bit. Keras is a higher layer API built on the Tensorflow. And this, what you see here, is the example of application written in Python for image recognition. The code runs on my PC, and we will be using here the pre-trained models. To start, you need to install first TensorFlow, then NumPy, and Keras. As you can see, loading the pre-trained ResNet 50 model here, it is just one line of code. And since this model is pre-trained already on 1,000 classes, we can just import the image we want to classify. Here, this image is TC51 JPEG. And then we will have the program will resize them to the dimension which ResNet 50 is expecting, is 224 by 224 pixels. If we have chosen another one like Inception v3, then it will be 299 by 299. Then we convert the image into NumPy array, then pre-process the image and run the prediction. So let's see how it works live. So originally, the code example comes from the training called Building Deep Learning Application with Keras 2.0. And when we hit the run, the program will compile and run on my PC in this window here. So you can see that it is the overlay of TensorFlow, and that my small GPU is asked to work harder than normally. It takes about 10 to 15 seconds, and it should finish the prediction. Yes, it is done, and you can see that TC51 looks more like an iPod than the wallet. it's already something which is basically true. So it is the most probable answer with 58% likelihood. Now we will change the model to Inception v3, and we will see the difference. I will outcomment. And the same story, TensorFlow starts. The GPU is starting to work. So now I swapped the model, which is also pre-trained. Okay, so now the results are here. We also can see that also Inception v3 is recognizing my device as iPod, but likelihood is almost 90%. And other classes are almost zero likelihood. Let me come back to the. So there are, however, two drawbacks of the application we just saw. First, that it runs on the PC, and I would like it running on my Zebra device, Zebra Android device. I want to be mobile. Second drawback is that it recognized my TC51 as iPod. I mean, it may look a bit like an iPod, but it is not an iPod. It is because the downloaded model was not trained on our images, and it never saw TC51 yet. What a shame. So I want to force the model to recognize our devices. If we want to add our images, we have to retrain the model to include them. And this is going to be our task now. We can achieve it in two ways. If we have time, good machine with strong GPU or cloud access, and a lot of images, then we can try to train the model from scratch. However, if we don't have it, we can use pre-trained models and retrain them using our images. Finally, when the model is ready, we will have to somehow transfer it to the mobile application. Pardon. Sorry. I tried to train from the scratch on my home PC. Imported about 300,000 train images from 1,000 different classes from ImageNet library, which was about 10 gigabyte of size. Then converted them to the special format called TF records and started training. It took 10 days on my small PC, and I had to restart the process several times. And as you can see, after 140,000 iterations, it started to behave asymptotic and did not improve much anymore. Probably I would have to run 1 million of iterations to tune parameters to get better results. So I stopped this training from the scratch method, but I did not give up the task as such. I took easier way, which is the use pre-trained models and retrain them as it is written in the tutorial TensorFlow for Poets from Pete Warden. There are basically 8 steps to follow, like download the reference project from GitHub, collect and prepare images you would like to recognize, and the rest is processing, including calculation of new bottlenecks. The details will follow in the next slides, retraining the model, then model conversion, transfer to Android app, and testing in on the mobile device. So let's follow these steps. Easiest point is to download or clone the project from GitHub repository. with this link. Then collect as many images of your object as possible and put them into object class folders. Important is to choose different images of the same objects. They should show the object from different angles, in the different light conditions, to generalize the model and to avoid so-called overfitting. As you can see, I've chosen 7 classes of Zebra devices. 1 barcode scanner, DS36, 4 different mobile computers, and 2 printers. And here on the right side is an example of the file structure. In DS36 folder, I copied all images of the scanner DS36. This graph is representing the Inception v3 model from Google research team, and it is here only to show you how complex the training task is, especially if you try to train it from scratch. Basically, when I trained from the scratch, I had to train all these layers. This is why it was so difficult and time-consuming. However, retraining the existing model is much easier because we train only last 2 layers located there where the magnifying glass is. The rest will stay intact. It means instead of millions of calculation, we will have only thousands to do. And this is the idea of transfer learning. Most of the knowledge learned somewhere in the Google Cloud will be transferred to my device. Cool, isn't it? And now let's look how these 2 last layers look like. 2 last layers are fully connected layer called bottleneck and the softmax output layer. As a courtesy of Google, we have the Retrain Python script to start right away. The script is downloading the Inception v3 pre-trained model and deletes last 2 layers. Then it takes our images and let them pass through the model. This way, it calculates new bottlenecks values for each image. The pink colored dots represent the nodes of the bottleneck layer. There are 2024 of them, and the red ones represent the output layer. It has 7 dots, representing 7 types of Zebra devices. They are fully connected. It means that altogether we will have only about 14,000 values to learn instead of many millions. So thanks to Retrain script from the tutorial, we get the new Retrain model. It can be even 80 megabyte large, depending on the model type. So it is basically too large for the mobile applications. It means we have to convert it to the TF Lite, TensorFlow Lite model, losing some accuracy, but reducing the size. We can do it using TF Lite converter. Then we copy this Lite model to the asset folder of our sample app, compile and run on our device. You can see here 2 files representing new model, GraphLite and labels.txt, located in the asset folder of my application. This model will be then mapped into the memory of the program. Then the program starts to capture images with the maximal resolution and display them for us. These images are then in the program resized to fit the model, then pre-processed and input to our model, which we already have in the memory. So the outcome then will give us the recognition probability of 3 classes with the highest probability. And of course, the time cost of the single inference process. So let's see how the application is running on my Zebra device. You can see here these 2 files representing the graph light, representing the model, and the labels representing the classes. It just takes the file. And when I run the app, it will install it on my device, my Zebra TC51, and run. Let's see how it works. Starting the compilation and building. Build was successful. And now I have prepared a few devices here. So it is the TC8000, and we can see that that the program is recognizing the TC8000 with the probability of 75, about 78%. And we move to TC75. It is also being recognized with almost 90%. Okay. The next is QLN, our printer. Okay, here there is no issue. It's 100% sure. It's so specific that it has no problem with recognizing at all. And the last is the DS36, which is also quite sure. The program is quite sure that it's the DS36. Again, QLN. TC75 and TC8000. Oh. In the end, I would like to answer the question from the beginning. Is it possible to make machine learning so easy and simple that everybody can profit from it? I would say yes. We saw how easy it is for iOS users to play with the machine learning, or how easy it is to develop using Keras on Tensorflow. We also saw, however, how fast it can become quite a complex task if we try to customize the process or train our own models. So to be more precisely in answering this question, I would support the statement I heard lately that in the future there will be 3 kinds of user groups of machine learning. Very narrow group of data scientists who will invent new models, train and tune them. Much bigger group of scientists and engineers, software developers from different areas who will implement those models, eventually retraining them, wrap them into application using machine learning frameworks like TensorFlow or others. And third, the biggest group of people, consumers, who will use machine learning consciously or not in applications delivered by first 2 user groups. I think all of these groups are going to profit from democratizing of machine learning process. The end, I hope not. I hope it's just the beginning for some of you who would like to code and develop new applications, or maybe improve the existing ones by connecting them with machine learning APIs. I think there is so much to be done and improved in any areas of our life. So please think about it. And thank you very much for your attention.
Awesome. Well, if you can hear me, this is Stacy. I'm back. Rafael, that was excellent.
Yes.
Thank you so much. I'm looking on the screen right now to see if we have any questions posed for you. And right now we do not. We'll give it a minute in case anybody else wants to chime in here. But I think seeing that you were incredibly concise and clear today, there's not a lot of questions, so that's always good. And I wanted to identify that for everyone that this particular Dev Talk, will have this taped and up on our YouTube playlist. Also announced again on our developer portal at developer.zebra.com. We'll let you know when we have the YouTube video available. And we'll also have a hard copy, a PDF copy of the presentation for review. And I'm hearing people chime in, nicely done. So excellent work, and we'll look forward to talking to everybody at our next Dev Talk in January. Thank you, everyone. Happy holidays. Have safe travels if you're traveling anywhere this year. Take care.
Thank you.
Thank you.